Alright, here we go. We are doing the video lesson for 9-4, factoring trinomials. And in this case, you'll see here in the title, it's in the form ax squared plus bx plus c. Ax squared refers to a number in front of the x squared, so you'll be having things like 3x squared plus 2x minus 8. Or something like maybe negative 4x squared minus 6x plus 2. Those would be two examples of trinomials that have a number in front of the x squared, so a coefficient of x squared other than 1. So something that's bigger than 1, which we did the problems in the last section where a was always 1, and we also learned in the last section that if a was 1, you had a shortcut you could use. You're not going to be able to use that shortcut in this section. So let's look here at example number 1. Now again, if you remember the last section, what we'd do with example number 1 is we would try to find two numbers that multiply. I'm actually going to move this over here. We're going to try to find two numbers that multiply to make 10 and add to make 27, which is pretty much the same thing we're going to do here, except the two numbers, we are not going to try to find two numbers that multiply to make 10 anymore. What you're going to have to do is, because there's a number in front of your x squared, is you got to take this a times this c. And again, when I say a and c, I'm referring to up here, ax squared plus bx plus c. So you first multiply your a and c together. So 5 times 10 gives us 50. So that's what we're going to try to find two numbers that multiply to make. Two numbers that try to multiply and make 50 and add to make 27. So again, you can go through your list of factors. You have things like 1 and 50. 2 and 25. Well, maybe I'll stop right there and say, wait, 2 and 25, I think that's going to work. 2 times 25 makes 50. 2 plus 25 makes 27. So that is what's going to work for this problem. So, like we did before, we're going to break this middle number up into the two numbers that I found, 2 and 25. So I'm going to have 2x plus, I'm going to make this a little bit smaller, 2x plus 25x. Okay? And then your first term is still your 5x squared plus 2x plus 25x, and then your last term is still plus 10. So now at this point, we have the exact same kind of problem that we had in the last section. You've broken up your middle term into the 2x and the 25x, and now we group factor. This first group, I'm going to factor out just an x, leaving me with 5x plus 2. Second group, I'm going to factor out a 5, so positive 5, leaving me with 5x plus 2, giving me my final answer here. The two pieces that got factored out, x plus 5, and the binomials that were left over the exact same, 5x plus 2. So there is the factored form of problem number 1. And again, you can always double check this by foiling that answer. Taking x times 5x gives you 5x squared, so on and so forth, and check it using FOIL. So let's look at the next problem. Again, we're going to start right here by saying 6 times 5 is 30. Now I'm going to try to find two factors of 30 that make 17. And I'm just going to do this right here now. I'm going to say I know that 2 times 15 will work, because 2 times 15 does make 30, and 2 plus 15 does make 17. So those are my two new middle terms, 2y plus 15y. My first term is still 6y squared. Last term is still plus 5. So now I group factor. First group, I pull out a 2y, leaving me with 3y plus 1. Second group, it looks like I pull out a positive 5, leaving me with 3y plus 1, which gives me my final answer, 2y plus 5 times 5y, or sorry, not 5y, 3y plus 1. So 2y plus 5 times the binomial 3y plus 1, done. Alright, why don't you pause the video and try number 3 on your own. I will give you a hint here. Pay close attention to the fact that this middle number is a negative 43, because you got to make negative 43. Alright, give it a shot. Alright, so hopefully this is what you did. You took 10 times 28 and got 280. Now, this would be one where maybe you do need to add a little bit of work here, because I'm not real sure on 280 what things multiply to make 280. Obviously, you know 1 and 280, but there's probably a lot more. So let's check. I'm going to do 280 divided by, I don't know, let's try 5. And we've got 5 and 56. Now, another thing I'm going to notice right away is that since I need these to add to be negative 43, I'm going to need both these numbers to be negative. Negative 5 times negative 56 will multiply to make positive 280, but it'll add to make negative 61, so that's not quite it. So let's keep trying. So maybe 280 divided by 6. Nope, that didn't work. 280 divided by 7, 7 and 40, so negative 7 and negative 40. No, that's not. That's going to make negative 47. So that's not it. Getting closer though. So now we're going to try 8, and yeah, 8 does work. 8 and 35. So negative 8 and negative 35, and when you add those together, you get negative 43. So that is what worked there. Negative 8 and negative 35. So now I come over here and I rewrite 10x squared minus 8x minus 35x plus 28, and I'm ready to group factor. So first group here, I'm going to take out a 2x, leaving me with 5x minus 4. Second group, careful here, you're going to need to take out a negative 7, leaving you with 5x minus 4 also. Good. So now our final answer here, 2x minus 7 times 5x minus 4. Done. Okay. So those are a few examples. I am going to now put a little reminder up here next to the first set of directions that you need to remember, and that is that, alright, so write this down. Before you reverse FOIL, you should always try to factor out a GCF. Again, you can pause the video and get that written down. But what that means is that before you do this, and if you haven't heard us call this reverse FOIL yet, you will. We kind of call this reverse FOIL because you're unfoiling to get the two original binomials. Before you try this, before you take, like in number 1, before you take the 5 times the 10, you should first double check and say, well, is there anything that I can factor out of all three of these things to make the whole problem smaller? Now, in our first 3 examples here, that was not the case. There was nothing that you could factor out to make the problem smaller, but that should always be what you look for first. And I'm mentioning that because that's going to come into play here in some of the next few problems. So, anyway, let's continue on with example number 4 then. And again, any of these that you want to pause and try to work out on your own beforehand, you should do that. So, for number 4 here, now that I've added that little reminder up there, let's first look at this problem and say, hey, is there anything I can take out of all of these terms. And the first thing I want you to do here is change that m squared into an x. There's not supposed to be two separate variables here, so this should be 24x squared minus 22x plus 3. So is there any GCF I can take out of all of these? And there's not in this case, because 24, negative 22, and 3, the greatest thing they have in common is a 1, and since the 3 does not have an x on it, there's nothing, there's no variables that they all have in common. So since there's no GCF, we're going to go back to our other method here of reverse foiling. So I'm going to take my 24 times my 3, and I'm going to get, what is that, 72. So now I'm going to try to find two numbers that multiply to make 72 and add to make negative 22. You might check a few things, and I find out that negative 4 and negative 18 is going to work. Negative 4 times negative 18 makes positive 72. Negative 4 plus negative 18 makes negative 22. So that's what I'm going to use. So now I write 24x squared minus 4x minus 18x plus 3, and I'm ready to group factor. So take out of the first group a 4x, leaving you with 6x minus 1. Take out of the second group a negative 3, so that you get that positive 6x minus 1 left over, giving you your final answer of 4x minus 3 times 6x minus 1. Done. Alright, example number 5. Again, now that I've given you that little hint, we're going to look here first and say, before I reverse FOIL this, is there a GCF I can factor out of all three terms? And in this case, there is. They all have a 4 in common. So I'm going to take that 4 out, leaving me with x squared plus 6x plus 8. Now, the big reason on why you want to do this is, in this case, I factored out that 4, turning this into a 1x squared problem. And if you remember, in a 1x squared problem, you can use your shortcut. So I'm going to use my shortcut here, because if the a is 1, I'm allowed to use my shortcut, meaning that all I need to do now is find two numbers that multiply to be 8. I'm going to write mult up there. Multiply to make 8 and add to make 6. Well, that's pretty easy. The two numbers that multiply to make 8 and add to be 6 are going to be 4 and 2, right? So that means you're allowed to use those two numbers and just use them in your binomial and write x plus 2 and x plus 4. Now, don't forget, though, that you've already factored out a 4, and so it needs to add on to the front here. So here is your factored form for number 5. 4 times the two binomials x plus 2 and x plus 4. Again, the x plus 2 and x plus 4 part foils to make the 1x squared plus 6x plus 8, and then distributing that 4 back in would give you your final, or your original answer back. So, again, that's the real reason why we look for that GCF first, because if the GCF is there, you might have a much easier problem to work with. Alright, and last one here you should try on your own. Again, pause the video, give it a shot, and then check your answer. Alright, so for the last problem, first thing I'm going to do is check for a GCF. In this case, again, there is a GCF. The GCF is 3. So I'm left with p squared plus 8p plus 15, which again, since this is a 1p squared, means I'm allowed to use my shortcut. my shortcut says, what are the two numbers that multiply to make 15 and then add to make 8? Well, that would be 3 and 5, right? 3 times 5 makes 15. 3 plus 5 makes 8. So we're good to go for our answer. Answer is going to be 3 times, the two binomials are going to be p plus 3 and p plus 5. Done. So always check for that GCF first. Alright, we're going to move on to the last example here before talking about another definition. And this last example here kind of goes with our definition at the bottom there. We look at this problem and we say, okay, well, we're going to see if we can factor it. So I'm going to first check for GCF. 3, 7, and 5, no GCF there. X squared, x, and no x's, no GCF there. So there is no GCF. So since it's a trinomial, I'm going to use my reverse FOIL. So I'm going to take 3 times negative 5, which gives me negative 15. And now I'm going to try to find factors of negative 15 that make 7. So I'm going to list them out over here. Again, I'm going to multiply to get negative 15 and add to get 7, positive 7. Now, the negatives are important here. So for negative 15, I have negative 1 and 15, negative 3 and 5, or 1 and negative 15, 3 and negative 5. So when I add these together, I would get 14 there, I would get 2 there, negative 14 and negative 2. None of these make 7. Now again, keep in mind, you could not say, yeah, but positive 3 and positive 5 makes 7. Well, first of all, that makes 8. Sorry, never mind. But keep in mind that the signs have to be the same. Sometimes you'll have one here where maybe if they were both positives, they would make that number, but they still have to multiply to make this negative number. So always double check your signs and make sure your signs are all correct. So nothing works here, which means that this polynomial is prime. This is a polynomial, a trinomial, that cannot be factored. The only factors of this polynomial are 1 and itself, which brings us to the definition of a prime polynomial. And we're simply going to state that as a polynomial, a polynomial that is not factorable, which we just saw there in example 7. Alright, so that is the new factoring, where a is something other than 1. We're now going to move on to some solving problems. Okay, so here's our 3 solving examples. These will be our last 3 examples. Again, we'll do the story problem, the next story problems together in class as bell ringer. So at the top of these examples, you can see here again a reminder that your equations always have to be set equal to 0 before you start solving these. So for number 8, do not attempt to factor this trinomial here. Do not try to factor this trinomial until after you've made this equation equal to 0. So to do that, I'm going to do both steps at once. I'm going to subtract 4 here, and I'm going to add 3a, which gives me my new equation here of 8a squared minus 6a minus 9 equals 0. So now I have it equal to 0. I can now solve. Again, we're solving by factoring here, so first thing I'm going to look for is a GCF, and I recognize that there is not one. It's 8, 6, and 9, nothing in common there. A squared a and no a is nothing in common there. So I'm back to my reverse FOIL method here. So I'm going to take 8 times negative 9, get negative 72. I'm going to look for factors, maybe set up my little factor tree or factor table here. I'm going to try to find 2 numbers that multiply to make negative 72 and add to make negative 6. So again, careful with your signs here. I'm actually going to do this over here in the table because I could think, well, 1 and negative 72, no. 2 and negative 36, no. 3 and negative 24, no. And again, notice that I'm always making the bigger number negative because since my 6 has to be a negative, when they add them together, the bigger number has to be negative. So I go through a few, I don't find any there that work, and then I finally find 6 and negative 12. 6 times negative 12 will make negative 72. 6 plus negative 12 will make negative 6. So that's what we're going to use. Alright, so we're going to rewrite 8a squared plus 6a minus 12a minus 9 equals 0. I am going to group factor. First group, I'm going to take out a 2a, leaving me with 4a plus 3. Second group, I'm going to take out a negative 3, leaving me with positive 4a plus 3. Again, equals 0. So now I rewrite 2a minus 3 times 4a plus 3 equals 0. Now you can use your zero product property and say this thing or both have to equal 0. So I'm going to say 2a minus 3 equals 0 or 4a plus 3 equals 0, which will give me my two final answers. In this case, I'm going to add 3 and then divide by 2. So a equals 3 halves, or 1 1/2, whatever, however you want to write that. And then in this one, I'm going to subtract 3. 4a equals negative 3. Divide by 4. So a equals negative 3/4. Done. Kind of a long problem there, but like I told you before, these problems will start getting longer. Alright, let's go ahead and try number 9 and 10 on your own. I think both of these can probably be done by yourself, and then come back and check the answers. Okay, so the expectation here was that you paused this video and attempted these problems on your own, so I'm going to go through these steps pretty quickly here because I'm assuming you're just checking your answer. Pause the video at any time if you need to. So for number 9 here, the first thing to do was to make this equation equal to 0. We did that by subtracting the things that were on the right side to give us an equation equal to 0. At that point, we multiplied our a times our c and factored it to make negative 14. So you can see here in my next step that a times c, 15 times negative 8 was negative 120, and then negative 20 and positive 6 made both of those work. Negative 20 times 6 made negative 120. Negative 20 plus 6 made negative 14. So I wrote those two numbers in the middle here. Now we're going to group factor. First group pulled out a 5b. Second group we pulled out a 2, giving us 5b plus 2 and 3b minus 4 as our two binomials. At that point, you set both binomials equal to 0 and solve both binomials. And at this point, it's a basic two-step solve problem. b equals negative 2/5 and b equals 4/3. So there was number 11 or number 9. Number 10, kind of the same thing here. The only thing you had to do here to make it equal to 0 was to subtract 20 on both sides, giving us 6n squared plus 7n minus 20 equals 0. Then we multiplied a and c. 6 times negative 20, negative 120. We found that negative 8 and positive 15 worked for our two factors. Negative 8 times 15 is negative 120. Negative 8 plus 15 is positive 7. They go in the middle. You now group factor. Pull out a 2n. Factor out a 5. The two binomials are 2n plus 5 and 3n minus 4. Since they equal 0, you're allowed to set each of them equal to 0. And again, solve. I skipped the basic solve steps here, but you should know them. Subtract 5 on both sides, divide by 2. Second equation, add 4 to both sides, divide by 3. You get negative 5 halves and positive 4 thirds. So there is that section, the ax squared plus bx plus c reverse FOIL section. Continue to work on your homework. Watch this video again if you need to practice these problems.